Are you
Just
sharing
wait
any
for.
Will now
screen?
be recorded.
Yes, yes, I'm sharing.
Because I
I'm
can just see
sharing,
that
but
blanks.
yeah, currently I'm not opening anything. Just I'm giving introduction to how many types of interrupts, how does IRQ line and all. Okay, now what if ISR means on behalf of my interrupt, what is the functionality I have to execute is called ISR routine. Similar way we have did for signals also, but that is user space. That's why you can write whatever you want. But now you're dealing with kernel space. That means you are blocking the current execution and executing another process. That means you must be take care of while writing an ISR. We'll come to know how this executes. You can see this picture, interrupt vectors. Can you see this picture? Interrupt vectors. This picture is visible or no?
Yes, it's visible.
Okay. Now for vector, what is interrupt vector is? So all, as I told you, your interrupt priority controller or interrupt priority interrupt controller have some pins according to the architecture. Say my Intel x86 architecture has 256 lines in as an interrupts for interrupt controller. That means it will support that many interrupts. And if any hardware is configured with that number, it will execute 256 interrupts, and they are categorized this way. So 0 to 19 are non-maskable interrupts and exceptions. So this is the software interrupts. These are non-maskable and exception software interrupts. And 20 to 31 are Intel reserved. And these are the external interrupts. From 30 to 127, I can configure my own interrupts. I can interface any of the hardware with this interrupts. And system calls. So you know that the system calls, there is an instruction called trap. So whenever a system call is called, the trap instruction will be executed and you will be moving from user space to kernel space. So trap is also an interrupt. So that's why the system calls are should be as less as possible that we discussed. Why? Because it has to go to the kernel space, come back to the user space, and it will take time, and it is also interrupt. Interrupt means it's a higher priority one and it is blocking the actual process. That's why you must be very careful in writing system calls. Too many system calls will lessen the performance of your process. So again from 122 to 238, there are external interrupts, and these are all reserved for future or some interrupts related to. This is APIC means Advanced Priority Interrupt Controller. This is all related to interrupt controller, which is of dedicated to x86 processor. This is not same for all processor. So there is table called interrupt vector table. That vector table is having all the information of which number is used for which interrupt. Okay. Now you can see in Linux everything. It's a number of in IRQ descriptor table or IRQ vector table. How many it will contain is the number of IRQ lines I have is equal to number of descriptor table entries I will be having. Each descriptor table, each descriptor table will have one action and one handler. As I told you, this is the table. See, everything in Linux kernel is a data structure. Kernel has a data structure called IRQ_desk. You know structures. You have to know about structures for understanding this. I have a structure name IRQ_desk, and it has the variables. It has member variables, status, handler, action, depth, and lock. These are the members of my structure, and it is a pointer, function pointer. That means in the structure also it is a function pointing to some other structure within the structure. And action also another structure. What does this contain is it contains a IRQ action, and this action have again one more function called ISR. This is where my exact functionality of my interrupt resides. So for everything you register, you have to register in the form of a data structure called IRQ_task. Okay, this is driver. So whenever you're writing any driver code, you have to create an instance of structure IRQ_action. So far we have seen different kinds of structures and created their instances, right? For knowing the PID_T is the structure. We have to create a variable of type PID_T. And then threads also we have seen, if you are creating a thread ID, you have to create pthread_T type as a structure type. Likewise, here also, if you want to register your interrupt, you have to create a structure driver, whatever the functionality you're writing for your ISR, you have to create a structure and you have to create a driver, and it needs to be an instance of IRQ action. And handler pointer will point to the handler pointer means these are the functionalities it will do. What are all functionalities you can do with your interrupt is you can hardware interrupt type, while shutdown it has to call, or enabling disabling must be there, acknowledging the interrupt. So this is the another structure pointing within the structure. An action is one structure which is having handler function, and this handler function is responsible for executing your ISR. ISR means interrupt service routines. That is the one executing on behalf of your interrupt. So that is the main one. So now we will see there is a user space. We have a proc file system, right? Logical file system. What is the use of proc file system? What is proc file system? You remember in file systems I have told you? Remember or no? Logical file system, persistent file systems.
User level
No?
debugging for
Yeah, user level debugging we can do. And what are the other things we can know? So we have lots of entries in proc file system, right? Whenever you create a process, an entry will be created in the proc file system with the PID name. This is RAM specific, that means session specific. When I terminate my code, then this PID will be no more present in this proc file system. Likewise, at that time only I have shown you about interrupts file in proc file system. Let us open that file. So you can see that these are the interrupt things I have for my proc file system. So here if you see, observe, there is a number for every interrupt. This is IR Epic means advanced priority interrupt controller, and this is a timer interrupt, and I8042 is generally used for keyboard, so that the IRQ number is 1, and like this RTC means real-time clock. Real-time clock will give you the date and time setting for your OS. So this is if anybody requested a time, then it will provide the time. The IRQ number is 8. So whatever you're seeing on the left hand side is the IRQ numbers and the driver names here. Whatever you're seeing is the driver names you are registered for your this interrupts. So whenever a keyboard interrupt occurs, this is the driver name I am giving, and this is information about any other interrupts. And the numbers you can see here, you have 4 CPUs here. Each interrupt, how many times it has been occurred in each CPU, it is the number you can see here. See this I80482 has occurred in CPU2 in 2,36,384 times it has occurred. And sound card, this sound interrupt has occurred 215 times in CPU. So this is the interrupt information you can see in the proc file system. And there is a header file called interrupt.h in in Linux kernel source code. One 142. There is a file called include linux interrupt.h. So there is a header file here. You can see this header file. So IRQ action I have told, right? You have to declare a structure of IRQ action, and I wanted to show you that structure. Okay, come to this computer. So first we see how many ways. First, what is the API we have to use for registering your interrupt, and how we have to do that PC, and we'll then come to this. Then you will have a good idea. Then better to go like that. So this is also, I'll let you know what are all this. So interrupt.header file will have all the interrupt related information about your OS. So now let us write a small snippet of code for how to register interrupts with your driver. Okay, I have to include this interrupt.h header file, and these common things are always common for every driver, init routine and exit routine, but there is a special function called request underscore IRQ. So if I want to register new IRQs from the interrupt vector table, this is the function I have to call. The first argument in that function is IRQ number. So now I am registering a number 19. So you can see there are 256 supported interrupts and external interrupts, or you have to see the range of them in that table. And if the range is in between the external interrupts, then you can pick any of the 19 value. So now if I want to use the same for dmessage, okay, when cat proc interrupts, 19 is meant for what? We'll just see. So 19 is not used by anything, and I want to check one command, lspci -b. So now here you can see Ethernet controller is having IRQ line number 9. What is the job of Ethernet controller? Sending and receiving the packets, right? Ethernet means what? LAN port, right? Network control. It's a kind of network interface. And you can see every hardware network controller is having IRQ number 47, and SMBus controller will have IRQ number 255. So I will just redirect this output to one file and show you what is this IRQ. So you can see now I have VGA. VGA means it's a graphic controller. For this, IRQ number is 45. And for sound, it is 49. And USB, it is 42. For every kind of controller, as I told you, everything is interfaced via controller, not directly connected with the hardware. These are all different controllers I am using in my motherboard now. So each controller will have IRQ number here. lspci is a command, will show you about what are all the PCI devices connected to your PCI, means it is a kind of bus. So controller and the hardware is communicating with the help of a bus. So we have different kinds of buses, I2C, SPI and PCI. So lspci will give whatever the buses connected as PCI as an interface between controller and the hardware. that will list you all this information about the devices. So now I have Ethernet controller attached for my shared IRQ number 19. This is the 19 number. So now for this Ethernet means if I send or receive any packets, if I execute this in Google Chrome, or if I send any HTTP request, so these are all the interrupts. So whenever I trigger that operation, then interrupt has to execute. That is the our motto. Now first thing is you have to, in init function, you have to declare one API called request_IRQ. This is the API you have to use for registering your interrupt. So 19 is already being occupied by Ethernet controller. Now I want to add my own driver with the same IRQ line. So that is possible. The shared IRQ means one line can be used by different drivers. The shared IRQ is possible. So you have to mention here one flag called IRQ F shared. If you mention like this, then this IRQ can be shared with different IRQ lines. So the first one is IRQ number. 19 is the number you have to pass. And next is the function. As I told you, the ISR routine. It is a handler function. When I enter this interrupt, what is the function it has to execute? The name of the function you have to pass. This is the name of the function, my_interrupt. And second one is what kind of interrupt you want to create, whether it should be shared or not shared, like that. And name of the driver you have to give. And there is a ID for every interrupt. There is a unique ID to define the interrupt handler. So that is the ID you have to pass. So now this is the 5 arguments you have to pass. First one is IRQ number, next one is function, and what kind of interrupt you are creating, and what is the driver name and the device ID. So you have different kinds of interrupt handlers, right? To identify the particular this handler, see for example the same IRQ 19, we have 2 different handlers now. So the processor has to know which handler has to execute, right? For that you have to pass the ID. This is a unique one for each interrupt handler. So this is I have to do in my init routine. After this is my function running. So whenever any this operation, any HTTP request is going on, this function will execute. This is called my ISR. So here what I am doing here, just incrementing the counter value, initializing the counter to 0 first, and incrementing the counter value. How many times this interrupt being called, I wanted to know. That's why I am just printing that counter value and returning from there. Okay, let us execute this one. I'll come to this exit. Exit section means request IRQ, free IRQ. Synchronize means, I'll tell you about synchronizing later. Module init, module exit, all are same like kernel module. So this template is same for every kernel module and every driver. Init routine and exit routine is common, and calling that init routine and exit routine is also common. Module, author, these are all same everywhere. Now I want to execute my driver make file. So this is, go to that make file and enable what is the file you want to execute. int test.o. Now make clean. Make clean will delete all the existing .ko files in the current directory. So there is no more .ko files now. So I want to compile the .c file into .ko by using make. Now if I give make, so make is ready now. .ko is ready. This is the driver ready for my interrupt registering. Now I check lsmod. Lsmod means list of modules currently being inserted. So now you can see where is my what is the name, init test.o. Look at that, where it has been just taking into one file. Why? Because the output we have to move back and forth. So this is not inserted yet. That's why there is no entry here. Okay, let me show after inserting. How to insert a driver? We are directly inserted into ring 0, right? How to insert a driver? Remember that command or no? Hello? How to insert a driver? I told you in, I think from last 2 classes we are discussing the same command. You remember iron small? Insert module? You remember this command or no? Okay, my driver is .ko is ready now. So now I am inserting. So first I want to check in the D message. Clear this D messages. I don't want to have any D messages. Just clearing D message -C. D message. Now no messages. And now ins mod int test.ko. Now it is inserted. I'll check in ls mod now. In ls mod, again redirecting to file, opening that file, and you can see my unit test is now in the module list of inserted modules. So likewise, if you want to verify what are all the modules currently inserted in your operating system, you can check with the command lsmod. So you have to remember 3 things: lsmod, insmod, and rmmod. Rmmod is to remove the module. And now if I check the D message, some error has come. Okay, let me check in cat proc interrupts. We have registered for 19, right? So now you can see there for 19 there is an entry called my underscore interrupt for my in the cat proc. Before it was not there, right? Did you observe the change here?
Yes.
That is 19 is the IRQ number, and for this IRQ number I have to, what is the shared IRQ elements? If you send any HTTP request, it will execute. Wait. Ethernet controller is responsible for handling HTTP requests. So if any HTTP request will go successfully, then it will tell you about the counter, what it is there. It will execute that counter. So while inserting, something has happened. Module verification has failed. Okay, let me do this for. Okay, I'm removing the module. I'll do this for keyboard interrupt. It will be easy. Int test.ko. Removing the module rmmod. I'm removing the module, and I wanted to share this number from 19 to 1. 1 means it is keyboard interrupt. This number is changed from 19 to 1. Again make insmod init test.ko. Now checking in cat proc interrupts. See now for the number 1, there are 2 interrupts now, 88042 and my interrupt. So this is a keyboard interrupt. Whenever I hit my key, the counter is incrementing, you can see here. So this is also hitting a key, right? So if I print D message also, that is keyboard. Keyboard I'm typing something, that is interrupts, all interrupts. So how many times I press my key, that many times the counter will be going on incrementing. This is the counter we are printing in this ISR, right? This is the counter value. So this is the one I am getting in D message. So what I did here, I have taken an IRQ number 1, which is my keyboard interrupt. For the same keyboard interrupt, we have used shared underscore IRQ. The shared underscore IRQ is for keyboard and also my interrupt, my own register interrupt. Okay, this is about how to register an interrupt with ISR, and what is this interrupt.h header file is. We will see what is that file, what does it contain, we will see now. This is clear how to register an interrupt. What is the function you have to see, remember is request underscore IRQ. Is this clear? Hello?
Yes.
Yeah.
So
Yeah.
what is the command to insert a driver?
INS mode.
INS mod and RM mod for removing module and LS mod for checking the LPs in the module. Okay. Now we'll see about this interrupt.h. It is present in include Linux source file of your kernel is present in user src directory. Include Linux interrupt. See now I am registering my handler with the structure of type IRQ written underscore T, and you can see this IRQ action structure what I was talking about. So in the interrupt descriptor table, let me show that picture. So this is the IRQ action structure. So you have to register your ISR with an instance of structure called struct IRQ action. This is the structure now. You can see what are all. So there is a handler here, IRQ handler underscore T. This is the handler function. This is your ISR function, and you have to register. There is a type def. You must know all these things in C language. What is type def? You know. So if I have too many big names, like big structure names, instead of using all these big names, I will write a small name by using type def. Okay, so that I can't explain now that type def also. So we'll just think. So it is just replacement of a big name into small name. So this is my IRQ action structure. You can have handler function here. As I told you, this is the handler function, and this handler function is the one you have to register as an ISR. And you can see here IRQ underscore T is the one you have to replace. Instead of this IRQ underscore handler underscore T, instead of writing this, you have to create with IRQ written underscore T. That is what we have created our function here. You can see IRQ written underscore T. This is my handler. And give the name of the handler, IRQ number and device ID. This is standard. This arguments and this type is always standard. What is changing is the name of the interrupt, your name of the ISR handler function, that will be changing. Okay, module param, we have another, I told you about this module parameter. While inserting a module, I can pass See now, I wanted to remove the module now. Again, insert the module by using module parameter. Now, what is the IRQ equal to? That is the variable I have given, I think. What is that variable? Yeah, IRQ is the variable. So I'm passing this dynamically now. IRQ equal to, say, some, we cannot give whatever value, just see in the Catrock interrupts and give that one. In addition to my interrupt, I am adding another interrupt of my own. So let us add for some sound card 49. 49. Okay. IRQ equal to 49. Sorry, insert module. INS mod IN test.ko IRQ equal to 49. Instead of changing in the code, I am now passing the IRQ number dynamically by using could not insert operation not permitted. I think it's not there in the list. So it's not there in the list. I can insert now. Okay, something wrong. So you know about how to pass this module parameter, right? I have shown one example in the second class itself, how to pass module parameters. I have passed some counter value and have checked the value in sysfile system and edited that value. Likewise, that is also possible with interrupt also. That's what I wanted to show you. Okay, you have understood, right? What is an interrupt, how to register an interrupt, and what are the do's and don'ts we have to write in ISR that we have to see. So let us say consider, see this diagram. Let us say I am having a ISR routine. This is my ISR routine, the one here you can see, right? The same like this. I have an ISR routine. Say for example, my ISR routine is in block state. That means an interrupt has occurred and it has to execute the ISR, but it is not coming out of that ISR. Then what happens at that time? What happens usually, you think? What happens? It is not executing the ISR. It is executing the ISR but not coming out of that ISR. It's not returning from that ISR. What happens at that time? Any guess? Any guess? Your entire system will be blocked, right? If the interrupt has to be interrupt latency. What is interrupt latency is the amount of time you are spending in executing an ISR must be very little as possible. Why? Because you are blocking the current process and executing a prioritized process, and you have to come out of this process as soon as possible. What happens if you take long time is your actual process is blocked here. You have to enable it as fast as possible. That's why interrupts are interrupt latency means the amount of time you have spent while executing an ISR is called interrupt latency. So it should be more or less. Interrupt latency should be more or less.
Less.
It should be less. So that is the only thing you have to remember in the mind while writing an ISR. So what are the do's you have to do is, it has to be as fast as possible, and you have not to do any memory allocations. If memory allocations are there in ISR, what happens? It will go and search in the entire memory location in the RAM, say 4 GB of RAM. It will go and see whatever memory is free and it will assign the pointer to you. So if the memory is too long, so the memory in the initial blocks is not free and it is only free at the end of the block, then it has to go and search every other block and give the pointer to you. So it will take time, right? Malloc call, dynamic memory allocation. You never guarantee this will return in this time. So that kind of things you should not do in ISR. And the second thing is, you should not make call any user related functions. Like any user space functions, you should not access those functions in ISR because it is in kernel context. And what are the other don'ts? Can you guess any of the other don'ts you have to consider while writing an ISR? Just think in a general scenario, like the interrupt service routine should be very less as possible. So now in that scenario, how can we write an ISR while considering what are the don'ts? For example, I have a big buffer, some 2 KB buffer with me, some 2 MB buffer with me. In that buffer, I am reading and writing data and processing the data. So processing the data means you will be getting a packet with all the headers, checksums and everything. Actual data must be present in the somewhere in the memory. In the whole packet, you will find the data only in some fields. So you have to extract those fields and you have to give the data for the user. For processing the data, it will take time or not. Consider the network interrupts only. You are passing HTTP request, you are receiving the data, and you have to process the data. So if I do all the things in ISR, what happens? I'll miss the other request, right? Sending and receiving packets in the network is very fast, right? It's in terms of milliseconds. So if I am doing all this collecting the packets and processing the data in ISR itself, what happens? There is a chance that I will miss the packets in the future. The coming packets I may miss. So for avoiding these things, you have to avoid big copy data transfers in ISR. That should be avoided. So what is the other thing, what alternative we have is, there is a other technique called bottom-ups. Bottom-ups means whatever the deferred work, that means less priority job, we are scheduling in terms of a function. Just collect the packet and call the function. This is the function, bottom-up function. So this function is running in parallel with your ISR so that you will not miss any packets. Just schedule underscore BH is the bottom-up. Call that function and execute this function. That's all. Okay? Clear that one? So the bottom ups are different types: soft IRQs, tasklets, and work queues. At this point of view, it is not necessary to learn more about that. If you are interested, I can share the material what I have, and I can have the examples also, sample files. If you are interested, I can share what are the bottom up mechanisms we can using in Linux. Okay. Am I clear?
Yes.
Yes.
So can anybody brief me out about the entire session and interrupts? Just tell me what is the different kinds of interrupts we have, what is interrupt latency, and how to register when interrupt, by means of which function, what the arguments to my function. Just brief me out, anybody, so that I'll be Can anybody do that, or you want me to do?
Just like that different types of interrupts is again repeating that when you have a phone call and all that's considered one type, and then you can like create your own types of interrupts in the system and put it if depending on what type of system you have. Then just briefly, I think you have to find an interrupt location which is not being used. Then you have to create a K file, and after the K file, um, then you can insert in whichever that line, the location you had mentioned. You use 19, and then you save that interrupt name that is there.
It is an ID, and it
Yeah,
is not needed. Whichever is not used is not needed. You can always have the shared interrupt line. It's ID. It's not a location. Okay, go ahead. So, what are the don'ts you have to consider while writing ISR? What is interrupt latency? Hello, am I audible, right? So, what is interrupt latency?
it's I think like exactly. It's like your system will process later by the time the interrupt is given. That there is like a delay. I'm not exactly if I'm putting it right way, but I think that's what it means.
Latency means the amount of time you're spending in executing the ISR. ISR means the interrupt handler, right? So the interrupt handler, whenever I trigger my interrupt, that handler should execute. So if it is taking too long time, then it is it will block your normal process, right? So that's why the latency means the amount of time you're spending in writing your ISR, in executing your ISR. So it should be as less as possible. Okay. While debugging, this is the main thing they will see. So there is a problem with your interrupt, and you are asked to debug about that. First thing you have to check is what is the latency of the ISR, and you have to do corresponding modifications of how to reduce the time of executing the ISR. So this is my ISR now. I have a counter here. This is executing very fast, so there is no blocking calls here. What if it is blocked for some reason? So in that case, you have to see that you have to debug in the ISR about what is the latency you are getting, and that is then one more thing is any blocking calls are there or any don'ts are there while writing the ISR. So if you do that one, then you will be debugged correctly about what is the problem in the software. This is request underscore IRQ function for registering your interrupt. This is ISR handler, and free underscore IRQ is for, and about the synchronize underscore IRQ is for verifying whether it is running or not. Okay. Verify this ISR is running or not means, see example, I have two different ISRs for the same IRQ line, right? So whether this ISR is running or not, it will tell you about synchronizer. Means synchronization means if you likewise what we did for unmounting in USB, mounting and unmounting. So the same here also, mounting means you have to synchronize the disk copy with the RAM copy so that both are in sync with each other. Likewise, synchronization is required while two ISRs are sharing the same IRQ line. No, it's not mandatory, but it always better to use. Free underscore IRQ means you have to free in this IRQ number while deregistering it so that it will be available for another interrupt. Okay, clear? Clear any doubts in interrupts? So by today we can complete our we have completed all the course. So I wanted to have a feedback from you, from all the four of you, like how it is benefiting for you, and can you share me the feedback by the end of the day? Is it possible?